Hello everyone, you're welcome back again. We're going to provide a solution to this Olympiad math problem. We are given that 5 to the power of x plus y is equal to 20 and 5 to the power of x plus 5 to the power of y is equal to 10. Then what is the value of 5 to the power of x minus y plus 5 to the power of y minus x? So to solve for the value of this expression from this equation, the first thing we're going to do is to name the first equation as equation 1, then we name the second equation as equation 2. Now to get this value, the first thing we're going to do is to pick this equation 2, which is what? 5 raised to the power of x plus 5 raised to the power of y, which is equal to 10. Now we're going to square both sides of this equation 2. So we square the left hand side and also we square the right hand side, so that when we expand this bracket, it's going to give us 5 to the power of x all square, then plus 5 to the power of y all square, then plus 2 of 2 multiplied by 5 to the power of x, then multiplied by 5 to the power of y, which is going to be equal to 10 squared implies 10 multiplied by 10, which is going to give us 100. So the next thing we're going to do is to recall that when we have a power raised to another power, we are free to multiply the two power together. So this is going to be the same as what? 5 to the power of x multiplied by s is going to give us 2x, then plus 5 to the power of 2 multiplied by y is going to give us 2y, then plus 2, then multiply by 5 to power x multiple 5 to the power of x. The base is the same. So using multiplication property of indices, we can write one of the base, then we add the power. So the first power is x plus the second power, which is y. So everything will now be equal to 100. So we apply multiplication property of indices to this place. When the bases are the same, write one of the base and add the power. So the next thing we're going to do is to observe. Here we have 5 raised to the power of x plus y. And from the given equation, equation 1, we are given that 5 raised to the power of x plus y equal to 20. So therefore, in place of 5 to the power of x plus y here, we're going to write this 20. So we're going to have 5 raised to the power of 2x, then plus 5 raised to the power of 2y, then plus 2, then multiply by. So in place of 5 to the power of x plus y from equation 1 is going to be 20. So everything will be equal to 100. So the next thing we're going to do is to take this constant, all this constant to the right hand side. So we have 5 raised to the power of 2x, then plus 5 raised to the power of 2y equal to, here we have 100, then 2 multiplied by 20 is going to give us 40. And when we take that 40 to the right hand side, it's going to become negative 40. So the next thing we have 5 raised to the power of 2x plus 5 raised to the power of 2y, which is going to be equal to 100 minus 40 is going to give us 60. So we solve this to be 60. Now we're going to keep this first. We can keep this, or we name this as equation 3. Then the next thing we're going to do, remember we are looking for the value of this expression 5 to the power of x minus y plus 5 to the power of y minus s from this given two equation. So we are going to rewrite what we are looking for. So what we are looking for is 5 raised to the power of x minus y, then plus 5 raised to the power of y minus x. Then this is what we are looking for. So the next thing we are going to do is to recall division property of indices. This can also be written as what? 5 raised to the power of x divided by 5 raised to the power of y. So this is equivalent to this using division property of indices. Then plus, this is the same as what? 5 raised to the power of y, then divided by 5 raised to the power of x. So this is going to be equal to, when we take the LCM, the LCM is going to be what? 5 to the power of y multiplied by 5 raised to the power of x. Then the LCM, the next thing is to divide. 5 to power, this 5 to power y will cancel this 5 to power y. We are left with just 5 to power x. And this 5 to power x multiplied by 5 to power x is the same as 5 to power x multiplied by 5 to the power of x. Then plus this 5 to power x will cancel this 5 to power x. We are left with 5 to power y. So when we use that 5 to power y to multiply this, is going to be what? 5 to power y, then multiply by 5 to power y. Now we're going to simplify further. So this is going to be equal to what? Remember, when the bases are the same, we just add the power. So we write one of the base, which is 5, then we add the power. X plus x is going to give us 2x. Then plus this place, the basis is also the same. So we write one of the base, then we add the power. Y plus y is going to give us 2y. Then everything over here also the bases are the same. We write one of the base, we add the power. So y plus x is going to be what? Y plus x. And recall from the given above, we are given that 5 to the power of 2x plus 5 to the power of 2y. We solve it to be equal to 60. So from equation 3, we're going to replace this to be 60 from here. So this is going to be equivalent to 60 over, and recall we are given from equation 1 that 5 to the power of x plus y, which is the same as 5 to the power of y plus x, is given as 20 from equation 1. So therefore, in the denominator, we're going to replace 20 in place of here. Remember that addition is commutative, so y plus x is the same as x plus y. So therefore, we're going to replace it as 20. Then 60 divided by 20 is going to give us 3. So because 0 here is going to cancel, then 6 divided by 3 is going to be 3. So therefore, the value of 5 to the power of x minus y plus 5 to the power of y minus x from this above two equation is the same as 3. Thank you for watching, and please don't forget to subscribe to this YouTube channel. Thanks.